I would like to now introduce our speaker. This is Coleman Jordan. He's a lecturer at Morgan State University School of Architecture and Planning and their graduate architecture program. Coleman is also the principal of Studio Cage, an interdisciplinary research design practice, and the co-founder of the not-for-profit organization in Canada called Corners. His projects focus on social justice and development in underrepresented communities, both domestic and international contexts. So today, Coleman will be presenting to us the Nubian Vault and illustrate the mudbrick process and its advantages for economic and educational growth in the building industry for local communities. It's a revival of the Nubian Vault construct and has taken hold in Sub-Saharan Africa. The rainy season continues to halt progress in Africa's more tropical regions. So with assistance from Dwell Earth, a company founded by two brothers in Texas, and the measured use of concrete, the Nubian Vault's failures have also demonstrated the potential for. Now, Professor Jordan will look at the history of the Nubian Vault from ancient Egypt to its 20th and the recent work of the French Burkinabé in La Voûte Nubienne. Professor Jordan, the floor is yours.
Okay. Well, thank you, Yvonne, for your introduction. And also I'd like to thank Carol, who's been behind the scenes for ACI. Carol Burles, I hope I got that last name right. Anyway, so I'd like to thank you, ACI, for this invitation and this opportunity to present a project that I've been working on a few years back and how we're actually proceeding in the near future with projects like this, I should say. Okay, so I'm going to present a sort of obscure project in the sense that this is the type of project we normally don't present at architectural presentations. It's a failure, a project that has that term in it, but has led to ways of success and how we move forward. And so I call this Rethinking the Nubian Vault in Sub-Saharan Africa. So first I want to start off with looking back at Hassan Fathy's sort of the forefront of re-looking at the establishment of the Nubian Vault structures that he spoke about much in his book on architecture for the people, or architecture for the poor, and looking at the economic values of using this, especially within areas within Africa, within also areas of the Middle Eastern regions. And it's actually quite efficient in its process. And Hassan Fathy, very well known for looking at how to begin to make different types of structures economical in their process. And he was also very well known for sort of getting away from the sort of straight line of architecture, the sort of modernist edge, and looking more at the context of a softer edge or a curved edge in his architecture that he felt spoke more softly to society and people and living in dwellings especially. So this is him in the center here. This is actually an image of him in New Mexico, where he's talking about the future of inhabitants in certain types of structures, because you have the opportunity for adobe types of the structures, which the Voûte Nubienne, which you'll see down the road, is one of the processes that is actually used. It's a adobe type of a system. And yeah, so that's the direction of this particular project. And so the Nubian Vault in itself, again, stems from its origins from ancient Egypt and the constructions of these vaults using the earth. The advantage of it was that using the earth and with the environment that it's in, especially within Egypt and northern parts of Africa, it dries easily, it hardens, and it's easily compressed. And whatever happens on the earth, whether if the earth shifts or moves, because it's made of the same material, it tends to last longer. So there are structures that still exist with this vault system. So it was secure, something that would last, and something that was efficient and economic to actually build with. And just as a note, so there's Hassan Fathy really revived this in the 20th century after ancient Egypt, and then what's happened in the 21st century especially is looking at the French Burkinabé, Brickinabé, I believe is the name of the pronunciation. But it's an NGO that has actually revived this Nubian Vault structure. Voûte Nubienne, it's a French organization, that's actually started to revive this, and they've revived it for, again, economic reasons within Africa in general. I'd say Northern Africa, but in general, they started to look at areas in southern Sub-Saharan Africa to see what the potential build would be in those particular regions. And I'll get to the point of why that becomes a bit important. So here's some of the potential of sort of modern techniques of Voûte Nubienne. You can actually go up fairly high. There's a typical equation that's used for how many bays you would use to create these vaults without compromising its structure. And then also the actual mathematical equation, which again, I'll show eventually in this presentation. But this is the type of structure, the more advanced types of structure. And what we're looking at is more dwelling types of structures. And the tools that are typically used for doing this, that we tried to minimize, or they tried to minimize today, the materials that would have to be used to begin to construct this Nubian vault. So it's very minimal types of equipment that would be used. And again, you are generally using the earth mix that you're actually on. And there is some testing that needs to happen as far as the type of soil. You generally want a soil, a sort of muddier soil that is at least going to stick to your feet, as sort of said. And that qualifies it as a material or sand or earth that will actually be good for build. And again, we're trying to minimize the tools and materials that are actually used for this process. So here's a part of the equation on the right here of this arch. It's really working in the context of thirds. And so the distance from the bottom of an arch to the bottom of left and the right of the arch is literally divided up into thirds. And then you have another third equation that starts to create the actual arch itself. And this would be the base, the end vault, the end of the vault arch. And so you've got a 1/3 to your left that creates this an angle that allows for another third, creating it at the other side, the right side of the angle. So this is generally the process. And when you see the builders as they build, they literally create this tool with string, whatever string that they have, which is apparent on your left. And also they will use the measuring device to make sure everything is balanced off as a third. And the distance is everything broken out into a third. And then they use a nail and a hammer to make sure that it's sort of stuck in place so that they can actually use the string to get the proper measurement. And it's measured around to create this sort of a bowed arch. Now, once that arch is created, there's another process. And it's important, and I'll show down the road, but this angle here of 70 degrees that starts to lean up against the base arch is a thinner brick than is built within the last, there's sort of the original arch. This arch here, that's the base arch, is a thicker block at the very end. Typically, it's a thicker block. And then you have a thinner block that actually leans up at a 70 degree angle that begins to help begin to do a corbel, which builds up one after the other and one after the other in an angle. And the angle begins to process and progress until you get this beautiful vault. And again, I'll show this down the road. All right, so here we are. Now, at this time, I was actually teaching at the University of Michigan. And I would bring a couple of students with me as this process began. And we were looking at the feasibility studies of how this would happen. And we took on a project with a group, Hassan Ali and Kenzie. We called them the clients, and they're artists as well in Senegal. Located in Joal, Senegal, Actually, where their position and where we started to build was a little outside of Joel. But what's important about Joel itself is that's where the first Senegalese president was actually born, and it's a very well-known place where tourists come to visit quite often, but it's not a very prosperous region. So the first president, Senor Leopold Senor, is located there. Generally, people will go there to visit for a couple different reasons. It's sort of a split 50-50, and those proportions may not be exact, but it's an area where there's Christian and Muslim that live together in these communities. They intermarry, and there's also a beautiful cemetery. They're made of shells. It's a shell island. And these shells on that island is a cemetery of both Muslim and the Christians that are on that actual island. And so it's a great place to visit if you ever get in that area. But anyway, the location itself, it's not a high economy based area. So what we were looking at and what Musana and Kenzie were concerned about were the issues of economy and building in this area. As the economy was falling out, it's on the water, so it's a fishing village as well. And as you may have heard in some of the news, a lot of people from this West African region, Senegal, were actually departing and leaving for Europe or other places, leaving the area. And so it became quite dangerous. There have been deaths along the way in the past of people dying on these smaller boats that shouldn't hold more than the people that they've been carrying. But anyway, it became an issue for Musana and Kenzie. And being artists that they are, they're willing to experiment and explore other options of trying to bring people to Joel, but then also the neighbors in the area to allow them to stay and begin to create their own economy and create their own housing. So the principal investigators, we invited a group of folks to assist with us. One of the people that's not shown is a chemist out of France that came to take some samples and created some paint samples along with this process. But at the top, it's myself. I was the designer, the built environment designer of the process. And then Musana Ali, she's an artist originally from Philadelphia, and she moved to Senegal. And she's married to Kenzie, who's an artist there in Senegal. Paula Gerstenblatt as well. She was, at the time, she was living in San Francisco. I believe she's in Rhode Island now. She's also an artist and I believe a sociologist now. Yeah, social worker. And Mamadou Sarr, who is very well known in the area, and he was sort of our political guru and our spokesperson for speaking to some of the public and helping us market that area. But he's also a sociologist and works a lot with U.S. NGOs that are in the area. And Amadou Kenzie is the husband of Musana Ali. And he goes by Kenzie. This is an artistic name, Kansi. And so as well, he's also very much one of the spokespersons for Senegal with the artist community especially. So again, the goal of our project was doing this construction of a complex to utilize locally accessible materials. So we didn't want to go beyond 50-mile radius of where we were located because we wanted the public to be able to access materials instead of going outside. And again, that's out of feasibility. Passageways is the name of Musana's organization. It's a Point de Passage in French. And within that organization, she works with a lot of artists around the area, local artists, to assist in building an economy for them and also giving them the space to do their artistic works and ventures. And again, the idea is to find an area to gather materials in a way that we can bring people together to do active roles within the built environment. So they're actually either participating in building their homes, meaning that we're trying to train some of the youth in particular, because the youth are the ones that are often leaving the area to go abroad. And so we're trying to train literally the youth in the area within understanding a build, how to actually build with their hands, and then also using materials nearby and also looking at the economic and the business opportunities of doing this. And so just to give you an idea of what I mean, the French organization, the French NGO that actually revitalized this process, has actually co-opted and worked with many other West Africans to begin to create their own construction companies from this design process. And again, it's not a new process. For example, Burkina Faso has actually been doing this for thousands of years and continue to at this point in time. And so we're trying to bring it in to, again, more the lower sort of middle rain regions of Africa. And I'll talk about that a little bit. So anyway, so again, we're trying to build structures that are going to reflect the people, but then also be economically feasible for them, and also create another line of economy. So it would be youth actually beginning to build and become their own contractors in the process. So our project, the location of it, just to give you an idea, Senegal is circled there in the red to your left, and it's literally the westernmost country that's closest to the US. At the very tip, you can see on the right side, there's a slide that shows Dakar, which is the largest city, the main city in Senegal, and Joal, which is much further down south. And both are located on the water. And that's what I was saying, that area there, the economy at the time was not very strong. So the idea was to try to make that economy, work with that economy and try to make it stronger so that the public would actually stay within their regions more. And again, that's sort of the goal. So one of the things that's important about this area, now we're building right outside of Joal. And it's in between Joal and another city called Mbojin. And sort of in the middle of it, it's sort of a non-space, non-area, but it's very rural and it's very open. And what you're looking at here is a satellite view, but this view is actually showing the fact that there are really no trees in this area. There are very few trees. You have the water. The land that you're looking at there is also, it's very dry, not much there. And the only thing that's really around there are a few palm trees and a few baobab trees. Now, the baobab tree is a tree that is a sacred tree. And let's just go back. This to your left is the baobab tree. And again, it's a sacred tree. They used to bury the, let me see, they used to bury, I can't think of the name of the figure, but it's the historian, basically. In the regions, they used to bury them inside. And there are a couple of places that are actually sacred cemetery spots in those locations. So those are the one tree. They're very medicinal as well. They're very much used as far as that, but people generally don't bother them in that region. So that's about all you'll see on this particular site. It's the baobab tree and a few palm trees that are there. So it's pretty barren. And because of that fact, we thought that that would be actually a good location to try this build because it's in between two locations. One, Mbojin is a fairly larger city, and Joal, which is a small city. And we thought the building in between those locations would allow bridging to begin to happen, where materials could come from Mbojin. And then Joal could actually use those and access those materials fairly well. So if you look at the map of Africa in general, the black space there is the tropical regions. And that's an area, again, that's very difficult to do a build that is totally adobe in the way that the Nubian Vault is built. And so experimenting where we're located in area, sort of the B area region, it's a sort of, and just to sort of back up that tree that I was referring to, the baobab, the burials are from the griots. So, but the griots are typically the historians of the culture. And so generally some of the trees will have a griot buried within them. And there's still some that actually do to this day. All right, so that being said, moving forward with this particular project. So the team that we collected and a couple of students that I had from the University of Michigan at this time came to to the site and worked with Musana, myself, one of the builders, Mustafa, who was working with us. And we all sort of collectively got together to begin to understand what it was we were trying to build and then plan. So the idea was that this was going to be experimental because we were going to test this process of Nubian Vault in this region that hadn't been done at the time. And so we were working with Mustafa, who had done some work with the French organization, the French NGO, and was collaborating with us as the contractor of the build. And so we went through a series of processes. We looked at the materials that were available to us within the 50-mile radius and had to decide if we were actually going to go with a traditional sort of brick that's in that region. That was sort of the original thought, that we were going to go with that before we looked at the Nubian Vault. We did some costing of it, and also one of the issues in this area is that there were not any trained builders in Joal and a few in Mojin. And so we again looked at the materials that are available, and also on site there's just tons of laterite in that area. And laterite in that region and in that location, laterite is very strong. And because of the strength of it and the context of it, we actually were able to collect that at fairly no cost because it's right there on site. And so we were actually able to collect most of that ourselves for the builders that we used to collect that. So we did go through some experiments before, again, we went to the Nubian Vault context. We just wanted to see what other materials were available in the area that had potential to build. Because we're near the water, there's a collection of seaweed that comes up seasonally. And so we collected a lot of seaweed, tried to implant that into the soil, which is very clay. So it's a black clay soil that exists on this particular site. And so we tried experimentations with that. Some succeeded, not strong enough. It was not like a straw that would bind it better, but that's what we were trying to look for, a typical type of binding. But it was an exploration that, again, we went back and forth and ended up with just saying, okay, let's just go with the Nubian Vault concept and this Adobe build that they use within that context. And they do use mixes of straw within that. And so that's where we began to work with. And so we had some of the students working with us that were very eager. They got their hands and feet muddied and working with the workers up there. And our planning, again, in the process, we're trying to begin to figure out the shape and the plan for what we're actually going to do. If this building succeeded, it was going to be used for literally the artists to begin to come together and have their sessions. However, because we weren't sure about the rain and also the context of this area being built with the Nubian Vault system, we really didn't know the strength of it and know if it was going to actually succeed. But anyway, so we went forward with a very basic design with one issue that was sort of back and forth between us. So before we did the actual build, we had this sort of groundbreaking ceremony. It was a ceremony that, again, Musana and Kenzie, who are artists, wanted to have a sense of a celebration before we actually go into the actual build. So they collected materials, they collected shells from the sea. There's actually some cement mix in this process, and it was sort of a journey, the circular form journey into a new beginning. Now, the Nubian Vault, again, the Brickinata out of France, this organization, this NGO that started the Voûte Nubienne. This is, again, what the structures would look like in full sort of complex that is more complicated, actually, than what we were actually looking for. But we got a lot of information from them and, again, started to look at the potential for what could be built in this particular area. Now, this is a building that is actually built within either Burkina Faso or going further north of the African continent. So the drier the area, the better. So our construction begins. And these are actually some of the blocks that we created. So within this diagram here, the exterior of this form is where you get the larger blocks before you actually start to build the vault itself. And so one of the issues that we were running into, and this had to do with some of the sort of a client conflict with the builders and also myself as putting this together. Now, the equation that I showed you earlier allows for a specific diameter, this sort of 3.3, these are done in meters. So like 3.3 meters is about a max that you want to go for this particular structure. And what was happening was in the second bay of the structure, the client, Musana and Kenzie, wanted to explore and push this a bit further. They wanted to push the idea further. And so let's expand this one bay and see how far it goes and see what we can do to get that done. The builder and myself were concerned about it because of the, I guess what we call the building codes based behind the experimentation that has gone on with the Nubian Vault in the past. However, one of the solutions that the builder came up with is to put a concrete post and beam structure for one of the elements and build upon that. And one of the concerns between the builder and actually myself was the expansion and contraction between earth, the natural earth that's on that particular soil, and the expansion and contraction of the actual concrete. And so again, that's when we just said, okay, this is just going to be experimental. We have to just make this. We had funding from the Vanoli grant out of the AIA, and so we were awarded some money to do this. So again, it just became an experiment. And if it succeeded, we would use it. If not, we would just take notes and move on. So the process begins. And what we did was invite, I think it was approximately anywhere between 13 to 16 masons. These are master masons coming from the Burkina Faso region. They're phenomenal. They work fast, they're diligent in their process, and they're very intense with the integrity of their build, and they know the system very well because many of these types of structures are built in Burkina Faso. And within that, what we also collected were 3 to 5 Senegalese from the Joal area that were younger to begin to learn and train in the process of the Burkina Faso builders. So the process began, we made many blocks. Again, this is all calculated with, from the builders and the contractor, the lead contractor, and processed this whole system. And again, they squeezed these out through stepping on in the mud, mixing straw and other aggregate that's within the area, smaller aggregate, to create this binding solution. And again, the laterite. The laterite was actually really good for a foundation because of the scale of the laterite. So within the mix of the block that was used as like a mortar, the laterite was the main system and the main component to actually create this foundation. And so that held good. That was actually quite strong and something that worked quite successfully. And you can see down at the bottom there, the actual builders. And it was like clockwork working with them. They literally have a system. I think the majority of the builders out of Burkina Faso are Muslim. And so they had their 5-day prayer, 5 moments, 5 periods of prayer throughout the day. And so after their morning prayer, they would come together and prepare meals, and then they would go out on site. And during the lunch period, we'd come back, and students from the University of Michigan, myself, we would all share these meals, which is traditional in Senegal and also in Burkina Faso, eating out of one plate. So we'd had a series of plates there for groups to eat out of. It's a great cultural experience, and it helped with the bonding of the workers themselves. So that actually helped as far as creating a good dialogue between everyone. So here's where this concrete post and column began to come into play. So as they're building the outside, the framing walls of the outside of the building, this concrete post and beam begins to become the element that's going to compensate the extended span that we're trying to relate and open up the bay to make it larger. And you can see it's hard to see where it's placed on here, but you can see the actual structure and how it looks as compared to the earth structure, because everything else is being built on the earth and the straw. So again, this is the bay here that became more controversial, and how we began to push forward is located about this location here, and it would be the one, I believe, to the right, not the where the stair is, but the one further to the right, this location. Okay, so the build continued, and again, you can begin to see the structure of the concrete beam and column. So one of the issues with, just to sort of back up a little bit, one of the issues with using concrete in this area is because of the economy base, concrete is very expensive in this location. And so that's why using the earth was really more economical for them. And that's part of the reason why we're trying to navigate ways to begin to build that the public has access to materials that they can actually afford. The other thing that happens, even some of the structures that have been there for long periods of time, they're not very well taken care of. And so because they're not very well taken care of, or they don't know how to take, a lot of the public don't know how to take care of them, but it's also a very harsh climate. And because of that climate, we want to try to make it more feasible for them. And they're also trying to look at very sustainable materials because they want to cut down on the electricity that is used in the city area, in the regions of Joal. And so again, with the concrete, they were using a lot more air conditioning and things of that nature. And so they wanted to back off of that as well. So sustainability is one of the goals in this process. But again, here in this, the lower three images here, at least you can begin to see the difference between the mix of materials. And again, that's, I think for myself, and I know for myself, and then also the builder, again, our concern was, is this going to work with the span? So the build continued. The arches are just, it's just phenomenal to see these masons build. They're very fast, they're very efficient, and they know what they're doing. They get the proportions and everything, which seemed very rough at the time, but they're very specific. And here you can see they're using oil cans to actually create, begin the creation of the arches. So this is the base arch that's used, the end piece. And this is the larger mason, the larger stones that are used to create the base, the larger bricks. It's just an image of the laterite. You can see the scale of the laterite, how large it is. And it's all along the foundation. And so that's what was used there. I would have used that in the mix. However, again, this is a very rural area. And so we didn't have the tools to break up the laterite, to break it down in any kind of a powder, to mix it in with the brick. So, and the masons are used to using the earth, and so that's what they used in this process. Just using the lighter mud for the construction. And here you can begin to see the difference between the earthen build and then the concrete build. It's there in the center. The strength of the arch is always tested along the way. They do this very religiously. They literally make sure that they test every arch that's built and make sure that it's strong enough before moving forward. And you can sort of see the line that's placed here. This is that line for the equation of creating these arches with that 1/3 component that I spoke of earlier. And then the scale of the brick, that 70-degree angle of brick that begins to take place when you start to corbel the actual vaults. They had to create those again. And those, as they create those, it's a different proportion, different size. It's thinner than the actual perimeter brick, perimeter blocking of the building. And so this here is a process of what they're doing. They actually create a frame and they stick within that frame and just repeat it over and over again, using the same mix, but just a thinner mix, repeating it. And this is a very good example of how it actually comes together. So again, with that diagram that I showed earlier, it's at that 70-degree angle, and it's built on top, corbelled on top of that, built over and over and over and over until eventually you get to the point where it becomes enclosed. And the gentlemen that are sitting on top of this vault here give you an idea of them, number one, testing it every step of the way, and also gives you an idea of how strong this vault actually begins to be. Now, part of the process is letting these dry for periods of time. And one thing that we didn't have was a longer period of time for drying, which is what we were hoping for. We wanted to start earlier than we actually did. But anyway, in that process, it started later in the year, and we have to actually, trying to actually rush through the dry and then do the build. And the builders, these builders from Burkina Faso are very confident in going forward. And so this one on the right is where it begins to close. And so that little bit of light up at the top there eventually goes out as they put in more of the mud mix there towards the end. And this is what you get at the top of the vault. Now, a floor will be built on top of that if you want to cover that. It depends on the actual plan of the building. But this is the main structure. And then again, you can build on top of that at least one layer. And then depending where you're, depending on the type of soil and where you're located, it can be built on more than 2 stories. But generally in the dwellings, you'll find 2 stories at the most in this particular area. And that's what we're testing out, a 2-story section. This is their son that was roaming around, Masana and Kenzie's son. Icarus is his name. And of course, he was running around excited. And I think at this point in time, he's actually considering architecture. He's just his last few years of art school, high school. But anyway, so this is the first level that's almost complete and almost there. We're beginning to celebrate a little bit more, and you can see the real rustic approach to this design. Although they're sort of building all these sort of, intuitive structures, intuitive scaffolding along the way. They're very familiar with the project and the process, and they really have come ready to build. So every day it's the same time in the mornings, and they end the same time at night, right before their evening prayer. And they're very strict about the time schedule and very persistent. So the first floor gets built, and as first floor gets built, we start to get news that the rain in the northern region is coming closer toward to the south, where Joel is located. And so the build had to begin to become quicker at this point in time because it was earlier than usual. The usual rain season in this particular region starts around July. And we were still into May at this point in time. So then this much gets complete, and we're happy, we're satisfied, we're celebrating. Everything seems to be okay. The concrete at this point is helping. It's not hurting, and everything we felt was okay. And one of the issues was that another holiday was coming up for those in Burkina Faso, the contractors. And so we were concerned again about time because we had to roof this thing quickly because we kept hearing about the rains. And so right after this is day one when we got this. This is approximately May, towards the end of May, early June. We're happy we can put something to cover the roof and keep moving forward. And then the rain season, which starts in June, October. And this was, so it was early, so it must have been around the middle of May when that image was. But typically it's between June and October. And the harsher rains do fall in July. But anyway, so the rains came a few days early, and this was what happened. That night, we looked at what was happening out there, and right where the concrete post and beam is where the collapse actually happened. And it would have happened from the soil, of course, getting wet, but those ends literally flipped. And when it flipped, the collapse. And so that was sort of the end of our experiment. And so we were actually glad that we stopped as far as making it something that was going to be livable, and also no one got hurt in this process because it was our time to stop, and we don't work in the rain anyway. But this is the process that happened, and so from there we decided we have to do something else, of course, if we're going to move forward with these designs. So the contractor was disappointed. Everyone was disappointed because we thought we had something that could actually withstand and stay, and we could build upon it down the road. But again, every failure leads to success, we hope. So that was our agenda. And I'm going to show you the process that is taking place for the sort of next build within this. And it's a company called Dwell Earth. Some of you may be familiar with it. All right, so Dwell Earth is a process that was founded by my father and his son. I met him in Detroit on another project separate from this, and we're doing a similar type of a project in Detroit, trying to find ways to begin to cut costs in building in certain locations within the urban settings of Detroit, and also trying to find just how you could actually build anything of that nature in an urban setting that would be out of a brick. And what Adam is the son. He's been there about 15 years, and this is his father, Bob. And so I've been in touch with both of them. And so we're talking about moving forward with the Nubian construction techniques, the Nubian Vault construction techniques, but using their process of build. And they've been able to construct buildings using earth in these locations where normally it would not be feasible to do, by calculating a sourced amount of cement that would save the region money as far as the cost is concerned, where they don't have to buy as much concrete to put into their builds. So they've been quite successful with their builds. So we haven't used them yet at this point for the Nubian Vault, but the idea is to go forward with using their product. Again, we do it as an experiment first, but if I go back to their homepage here. Part of their technique by using this compressed earth, and this is the context of their product, is that it's been tested. It's been tested over years now of the strength, and so it's been classified as a strong enough brick for building. They've done this in developing parts of the world. They've done this in sort of rainforest areas of the world as well, and so we're hoping to begin to use them with their history, because of the fact that it cuts down on cost, it's sustainable, and it's environmentally friendly. And so, for example, the general build, they do a test of the soil, just like we would do with any design build that's going to be using any type of adobe. You want a sort of a sticky mud that's going to at least, again, stick to your feet, sort of a test. But they do an actual chemical sample of it as well in their process. And in general, they're using about 15% of the build of the mixture of concrete and their earth block. And again, it just depends on the location of where they are and how that actually connects to their build. So they have a whole equation of how they actually get there using this sort of earth block. And this system here, this mechanical piece that they use, is efficient enough to actually bring to a rural location that does not have much funds to train builders to use this, and then to begin to produce these types of blocks. Now, when I worked with them in Detroit, we were actually able to train builders to use it, and it's efficient, works easily enough. Now, the only thing, they're generally using a straight block, and they have a specific proportion right now that they're using. So again, ours would be a test of understanding how thin they could actually get it and what proportions would actually change within this actual build. And if we get this to work for us, we will use it for other structures down the road. So again, this is their website, it's Dwell Earth, and this will give you an idea of the map that I showed earlier and locations that they've been working. So Senegal is approximately right here. And so their builds actually a little further down south. This would typically be the rain regions, the more tropical regions of Africa. And so the fact that they're building even further down and in the more tropical regions gives us hope that we can actually begin to meld these two processes together and hopefully have them work. Okay, so I'm just going to end with this image because this image actually matters for us. One of the things that actually helps with a lot of the build in this area is the fact that that earth, although it's solid, has a lot of cow dung on it, or cattle dung in that region, which also helps with the soil. And these cattle roam from the Fulani, who are the nomads of this region. And they walk up and down. They actually are part of it's depending on who you speak with, they're either part of the problem of the vegetation that doesn't exist in this region, or they're part of the regions that help the development of the area because they have cattle in this area. And also it does help the soil if you're going to actually build in this region. It also gives an idea of the sparseness of the trees that are located in that area, that region. So the palm trees are about as sparse as you see in this image here. And the last thing we had we had a dialogue with these cattle as we had one fenced in area that Masana and Kenzie have been growing plants on a regular basis. And what's interesting, you have to really protect that area, and they try to fence it in. And we were working one day, and the cattle came in and were just grazing freely on their papaya and all the other types of vegetation that they were growing. So it's sort of a conflict between the Fulani and some of the public in that region, some of the locals in that region. That's a sort of a love-hate relationship. But anyway, with that being said, thank you for your patience, especially with this presentation. But thank you